150 million kilometers away, something enormous has just happened. The surface of the sun erupts. A massive cloud of electrically charged particles is blasted into space at tremendous speed. At first, nothing changes on Earth. People still drive to work, planes cross the sky, phones connect, power flows through cities. Most people have no idea that an invisible storm is racing toward the planet. But scientists are watching, and if the eruption is powerful enough, the world may have only hours or days to prepare. This is not a hurricane. It is not an asteroid. It is a storm from the sun. And almost every piece of modern technology could feel its effects. The sun may look calm from Earth, but it is anything but peaceful. Its surface is filled with intense magnetic activity. Magnetic fields twist, stretch, reconnect, and sometimes release enormous amounts of energy. One type of eruption is called a solar flare. A solar flare releases powerful radiation. Another event is called a coronal mass ejection, or CME. A CME can throw billions of tons of charged solar material into space. Most eruptions never hit Earth. They may travel in another direction entirely. But when a powerful CME is aimed directly at us, scientists begin paying very close attention. Because Earth is about to enter a giant cloud of electrically charged material moving through space. The storm does not reach Earth immediately. Depending on its speed, the material can take roughly a day or several days to cross the distance between the sun and our planet. That delay gives scientists something extremely valuable: time. Space weather observatories study the eruption. Researchers estimate its speed and direction. Government agencies alert satellite operators, airlines, power companies, and other organizations that could be affected. For most people, everyday life continues normally. But behind the scenes, engineers begin preparing for something they cannot stop. Nobody can turn the solar storm around. Nobody can block it with a missile. Humanity can only prepare for its arrival. Fortunately, Earth is not completely defenseless. Our planet is surrounded by a magnetic field. You can think of it as an enormous, invisible shield extending far into space. When charged particles from the sun reach Earth, the magnetic field helps redirect much of that material around the planet. Without this protection, life on Earth's surface would face a very different environment. But the magnetic field is not perfect. A sufficiently powerful solar storm can disturb it. And when that happens, the effects can spread from the upper atmosphere all the way down to technology sitting on the ground. The first signs may appear hundreds of kilometers above us. Satellites are among the most exposed pieces of modern infrastructure. They operate above much of Earth's protective atmosphere. During a strong solar event, increased radiation and charged particles can interfere with satellite electronics. Sensors may produce incorrect readings. Communication systems can experience problems. Satellite operators may place spacecraft into safer operating modes. Some systems may temporarily shut down sensitive equipment. Satellites in lower orbits can face another problem. The upper atmosphere can heat and expand during strong space weather. That creates additional drag. A satellite that normally moves through extremely thin air suddenly encounters slightly more resistance. Its orbit can begin changing. For spacecraft already close to Earth, even a small increase in drag can matter. Then, navigation systems may begin noticing the storm. GPS signals travel from satellites through Earth's upper atmosphere before reaching receivers on the ground. During strong space weather, disturbances in the ionosphere can affect those signals. For an ordinary driver, the result might only be reduced accuracy. But GPS is used for far more than finding a restaurant. Aircraft use satellite navigation. Ships use it. Surveyors depend on it. Farm equipment can use precise GPS guidance. Construction projects use positioning systems. Emergency services use location technology. And thousands of businesses rely on satellite navigation every day. The stronger the disturbance becomes, the more important backup systems become. Radio communication can also be affected. Certain high-frequency radio signals travel long distances by interacting with layers of Earth's atmosphere. Solar radiation can suddenly change those layers. During strong events, some radio communication may become weaker or temporarily unavailable in affected regions. This matters especially for aviation. Aircraft traveling over oceans and remote polar regions do not always have the same communication infrastructure available over land. Airlines may adjust routes. Pilots may use alternative communication systems. Flights could experience delays or longer paths. Again, airplanes do not suddenly fall from the sky. But the invisible systems supporting global aviation can become less reliable. And then something beautiful happens. Charged particles interact with Earth's atmosphere and create auroras. Normally, the northern and southern lights are most common near the polar regions, but during powerful geomagnetic storms, auroras can spread much farther toward the equator. People who have never seen them before may suddenly look outside and discover glowing curtains of light moving across the night sky. Green, purple, red. For many people, this may be the only visible sign that something extraordinary is happening. But the same storm creating that beautiful sky can also create serious problems for technology below. One of the greatest concerns during an extreme geomagnetic storm is the electrical power grid. When Earth's magnetic field changes rapidly, it can create electrical currents in long conductive systems on the ground. Power transmission lines can act like enormous pathways for those currents. Transformers and other grid equipment may experience unusual stress. That does not mean every solar storm causes a blackout. Most do not. Grid operators closely monitor space weather conditions and can take protective steps. But an exceptionally powerful storm could create serious challenges. And because the modern world depends on electricity for almost everything, protecting the grid becomes one of the highest priorities. Imagine a major region experiencing a power disruption. At first, backup systems activate. Hospitals switch to emergency generators. Data centers rely on backup power. Critical facilities follow emergency procedures. But if a blackout lasts longer, secondary problems begin appearing. Traffic signals stop working. Gas stations may struggle to pump fuel. Some cell towers eventually lose backup power. Stores cannot process normal transactions. Refrigeration becomes a concern. Water systems may require emergency electricity. None of this means a solar storm automatically sends civilization into chaos. But electricity connects almost every system around us. When it becomes unreliable, the consequences can spread quickly.
What about the internet?
A massive solar storm would not simply erase the entire internet. Most global internet traffic travels through terrestrial networks and fiber optic cables, including enormous cables crossing the ocean floor. Those cables do not depend on satellites to carry most everyday internet traffic. But the infrastructure supporting communications still depends on electricity, networking equipment, data centers, timing systems, and many other technologies. Satellite internet users could face more direct disruption. Remote locations relying heavily on satellites could lose connectivity. If electrical problems became widespread, internet service could also fail indirectly. The internet might survive the storm, but your ability to reach it could become another story. Modern finance also depends heavily on technology. Banks use enormous computer networks. Markets rely on precise timing. Electronic payments require communication between multiple systems. Many of these networks have backup systems and emergency procedures. A solar storm would not make money disappear. Your bank balance would not suddenly vanish because the sun erupted. But if electricity and communication networks suffered major interruptions, accessing financial services could become difficult. ATMs might stop operating in affected areas. Card transactions could fail. Businesses might temporarily return to cash. The problem would not be that the financial system forgot who owned the money. The problem would be reaching the system that keeps track of it. This is why space weather is monitored constantly. Scientists observe the sun. Satellite operators watch radiation levels. Power companies study geomagnetic conditions. Airlines receive warnings. Government agencies coordinate information. If an extreme storm is approaching, organizations can take steps to reduce risk. Satellite equipment can be protected. Power grid operators can modify operations. Some flights can be rerouted. Sensitive systems can be monitored more closely. Preparation does not guarantee that nothing goes wrong, but knowing that a storm is coming can dramatically improve the response. Humanity cannot control the sun, but we can become better at living with it. History gives us an example of what an extreme solar storm can look like. In 1859, Earth experienced one of the most famous geomagnetic storms ever recorded. It became known as the Carrington Event. Auroras were reported unusually far from the poles. Telegraph systems experienced dramatic electrical disturbances. Some operators reportedly found that electrical currents induced by the storm were strong enough to interfere with their equipment. But the world of 1859 was very different from ours. There were no communication satellites, no GPS, No global digital economy. No modern electrical grid. Today, the same kind of extreme event would interact with a civilization surrounded by electronics. This is where the story often becomes exaggerated. A solar storm would not automatically destroy every phone, car, television, or computer on Earth. Your smartphone is not likely to suddenly explode because charged particles reach the planet. Most ordinary electronics on the ground are protected by Earth's atmosphere and magnetic environment. The larger concerns involve systems that are exposed to space weather or connected to enormous electrical networks. Satellites, radio communication, navigation, long power lines, high-voltage equipment. The real danger is not every electronic device failing simultaneously. It is disruption spreading through the infrastructure connecting modern society together. The outcome depends on the strength of the storm. A mild event might create little more than beautiful auroras and temporary communication issues. A stronger storm might disturb satellites, GPS accuracy, radio systems, and power grid operations. An extreme event could create much larger problems, especially if critical infrastructure were damaged. But predicting the exact consequences is difficult. Modern infrastructure includes protection systems. Engineers understand space weather much better than people did generations ago. Satellites can be designed with radiation protection. Power grids can be monitored. Warnings can arrive before the strongest effects. The future is not simply about fearing solar storms. It is about building systems capable of surviving them. Eventually, the storm begins to weaken. Earth's magnetic field settles. Radio conditions improve. Satellite operators begin returning systems to normal. GPS accuracy stabilizes. Power companies inspect their equipment. Scientists continue watching the sun. If damage occurred, repairs begin. The world starts returning to normal. And for most people, life continues. But something has changed. For a brief moment, humanity has been reminded that the technology surrounding us exists inside a much larger environment. An environment that begins far beyond our cities, far beyond our atmosphere, all the way at the surface of the sun. The sun gives Earth almost all the energy that makes life possible. It warms our oceans, drives our weather, feeds plants, and lights every day. But the same star that makes life possible is also capable of sending enormous storms across the solar system. Most will never seriously affect us. Some will create beautiful skies. Others may challenge the technology modern civilization has learned to depend on. The next massive solar storm may arrive tomorrow, or years from now. We cannot know exactly when, but scientists are watching, engineers are preparing, and every new warning system gives humanity a better chance to respond. Because the question is not whether the sun will erupt again. It will. The real question is what happens when the next truly massive storm is aimed directly at us, and whether the world we have built will be ready when it arrives. This is Dream Frame TV, where science reveals just how extraordinary our ordinary world really is.